Alright, zeros of a function. In many situations, it's useful to know what number will make a function equal to 0. So what input would I have to put in to get an output of 0? Now, suppose I had a function that told me how much money would be in my bank account at any point in the future, based upon how much money I make as well as my expected expenses. I'd be very interested to know what time that function would be equal to 0, so I could put more money in that account. So again, a zero of a function is the value you put in for x or for whatever the input variable is, so you get 0 out. And there's something you need to remember about the property of 0. 0 times any number is 0, right? So if I have 0 times x, I'm always going to get 0. So what if I add two values, a times b, and I know the result was 0, or I wanted the result to be 0. What would have to be true about at least one of those values? If one was 6, what would the other one have to be? What would have to be 0? So a times 6 equals 0. What's the answer for a? A is going to have to be 0. Or both values could be 0, because 0 times 0 is 0. So when we're looking at a product, when we're looking at several factors that are being multiplied together, when we want them to equal 0, at least one of those factors has to be 0. So when we look at this first example, is 3 a 0 of this function? Well, the way to find out is to put 3 in for x and see if we get an output of 0. So let's go ahead and do that. F of 3, will it make this function equal 0? So let's put it in and see. 2, take out the x, so 3 to the second power plus 7, take out x, put in 3, and then plus 4. And we can do it in our head, or we can do it in our calculator. Let's see. Oops, that's a minus sign here. Let's make that a -7 then. Okay, I forgot the minus sign. That's going to make a big difference. Alright, so we're going to put this into our calculator. So 2 parentheses 3, and we're squaring that. Subtract, don't add like I almost did. Subtract 7 times 3, and then add 4. And I get 1. I don't get 0. So my answer then would be 3 is not a 0 of this function. It did not make an output of 0. And we could keep trying different values, guessing and testing, until we find out what makes it 0. But for now, we know that 3 is not. Alright, the next problem, we're going to try a variable expression, actually a complex expression in the function, to see if that gives us 0. So not just putting in one single numerical value, but an entire expression. Let's try that. We're going to do f of 1 plus 2i. Now remember, I is that imaginary number, so we have to be careful when we're working with it. We have to remember that I squared is -1. Now, we're going to take out all the x's, and I'm going to leave a pretty big pocket when I do, because I'm putting not just a single number in, but an entire expression. So let's get it ready first. Blank squared, for x squared, oops, I keep forgetting those minus signs, minus 2 times blank, where the x was, plus 5. And what are we putting in? We're putting in 1 plus 2i. 1 plus 2i. Alright, now this gets a little bit complicated, because anytime we have a binomial expression and it's being squared, we have to remember that it means times itself. So 1 plus 2i to the second power is 1 plus 2i times itself. And I need to write it out like this. Subtract 2 times 1 plus 2i plus 5. Now we're going to do all the multiplying. And remember, you've got a binomial times a binomial. You should get 4 terms when you multiply these out. You can either set this up in the box method. I can show you what that's going to look like off to the side if you want to do it that way. 1 and 2i here, excuse me, and 1 and 2i here. you know what, let's go ahead and just do the box method, because I think it's going to be really easy for this problem. 1 times 1 is 1. 1 times 2i is 2i. This 1 times this 2i is 2i. And 2i times 2i is 4i squared. Alright, now we need to simplify. So we get this 1 plus 2i plus 2i is 4i. And then 4i squared, remember what that is? That's 4 times negative 1. 4 times negative 1, which is minus 4. Alright, add our like terms together. 1 and negative 4 is negative 3 plus 4i. So we're going to bring this back up, and we're going to put it into the expression right here. We found out that all of this multiplied out to negative 3 plus 4i. Alright, now here we're going to distribute the negative 2 times the 1 plus 2i. So again, think of that as a negative 2. Negative 2 times 1 is minus 2. Negative 2 times 2i, negative 4i, and then plus 5. Alright, we're getting there. Now we're going to add together all of our like terms. So let's do the numerals first. We have negative 3, negative 2, and positive 5. Well, negative 3 and negative 2 make negative 5. Add that to positive 5 and I get 0. These just go away. Now I've got plus 4i and minus 4i. Plus 4i and minus 4i makes 0i. So I've got 0 plus 0i, which is just plain old 0. So when I did the function of 1 plus 2i, when I put that into this function wherever x was, the output was 0. So we conclude with 1 plus 2i is a 0 of the function. And we write that conclusion out in order to answer the question.